Page 57 from the textbook. So it's defining the moment of a force. So the moment of a force is the turning effect of a force about some axis or point, usually called a pivot. It's defined as follows. So the moment is the force times the perpendicular distance of the line of action of the force about the axis or point of rotation. And moment is F times X. So it's got the SI units, Newton meters. So there's an example here. If I just copy this here, then we have got a handle, and here's a pivot point. So the handle is rotating around this pivot point, and you're applying a force F at a certain distance x from the pivot point. And in this case, it's at right angles. So straightforwardly, you can just use the moment is the force times the distance because it's perpendicular. So you could just do moment is force times distance, and that would give you the moment. But in more difficult questions, the force will not be perpendicular. You'll have to use a bit of trigonometry. So if I just get rid of that up to here and have a look at this bit. So here is one that is not perpendicular. So we've got a force acting on a piece of wood, and the pivot point's here. So there's the pivot at this point. And the action of the force is at 0.2 meters from F, but F is not acting perpendicular. It's acting in this direction. So you need to find the perpendicular distance to the pivot from the line of force. So you draw a line down like this from the line of force, and then you draw a line from the pivot directly to the line of force, and that forms the perpendicular distance. So the perpendicular distance is here, it's x, so that's the perpendicular distance. So this distance here is not the perpendicular distance, it is this distance here. So a lot of these questions will use trigonometry. It'll either be cos or sine. So it might be like, say, moment is the force times x cos theta, or it might be sine theta. It just depends. It depends on the setup of the question. But we'll go through examples of each one. The next part talks about the principle of moments. So when a body is in equilibrium, the net force acting on it is zero, and its net moment is zero. So you can use the principle of moments to solve problems where an object is in rotational motion. You'll see this kind of stuff in mechanics as well in maths, lots of moments questions. So we'll go through loads of those, but let's go on to the next page.